Okay, hopefully this video will help you out. So a little change to this problem, I slashed off 3 of those dots. So in a pattern of 3, 7, 11, I want you to find the 0 term and the 65th term. So to find each, you need to know that number you're adding each time, which is my common difference. You use that to go backwards to find that 0 term, and I could use that to find both answers. So for this, first term is 3, second term is 7, third term is 3. Third term is 11. I'm adding 4 each time, so my common difference is 4. To find that 0 term, I'm doing the opposite of adding 4. I'm going to the left, subtracting 4. So taking that first term, 3, subtracting 4 gives me the 0 term. 3 minus 4 is -1. And that makes sense because if I take that -1 and I add 4 to it, -1 plus 4 is 3. 3 plus 4 is 7. 7 plus 4 is 11. 11 minus 4 is 7. 7 minus 4 is 3. 3 minus 4 is -1. Make sure you understand that. So that 0 term is -1. To find the F65 term, I'm going to find the explicit function by using the 0 term and d. I'm also going to show you eventually in the video how to go back and use the first term and d to the x minus 1, so make sure you're okay with both. But for this first method, I'm going to take the explicit function using the 0 term and d. So that is f of x equals f of 0 plus d to the x. So I'm going to skip ahead here a little bit. So again, to find that, I use f of x equals f of 0, the first term, or the 0 term, I'm sorry, plus d times x. I could also use the first term plus d times x minus 1. So again, make sure you're okay with both. So the 0 term, when I plug that in, is -1, goes right there. The common difference 4 I'm adding goes right there in front of x. So I get f of x equals -1 plus 4x. Make sure you write it both directions. Make sure you write it in slope-intercept form. So that's 4x minus 1. So f of x equals 4x minus 1. To find that 65th term, I'm going to replace that x with 65. Take that equation over here, and where that x is, plug in 65. Here's where I'm really doing math. This is just the notation. So here I am going to do the actual math. So 4 times 65 gives me, if I do that correctly, 260, I believe. So I get the 65th term is 260 minus 1, which is 259. So again, 259. Knowing also I could have used f of 1 plus d to the x minus 1 to get that same equation, which I'll show you later. So for that, shrink that down. Alright, problem number 2 is a heavy hitter there with big negatives, so I'm going to find that common difference first by subtracting 58 and 44 and comparing that to 44 minus 30. So again, with a heavy hitter, find the common difference. So what I did there is I took that 58 and I subtracted 54 or 44 and I got 14. And then I also subtracted, so let me go back. I think I did that somewhere. Oh, I guess I didn't. So again on this, I know I'm going up by 14. 58 take away 44, just the raw numbers, gives me 14. If I take the raw number 44, take away 30, I also get 14. So again, it has to be 14. -58, adding 14 to it cancels away some of those negatives and gives me -44. Adding 14 cancels some of those negatives and gives me -30. When I'm going to the left, I'm combining more negatives to it. So -30 subtracting 14 is -44. -44 subtracting 14 is -58. So make sure you're okay with that for this big negative number. So that means if I'm going to the left of -58, I'm going to take and combine 14 more negatives with it. So I'm going to get even more negatives. So negative 58 combined with negative 14 gives me negative 72, I believe. And again, that makes sense. Negative 72, more negatives going to the left, less negatives going to the right. So I'm going to use that common difference, which is 14, and that f of 0 to write both equations here. So the recursive equation is always f of x equals f of x minus 1. Again, a fancy way of saying to find any term, always use the term before it and add 14. So to find this term, use the term before it to add 14. That's the recursive pattern. That's the recursive equation right there. It's not having you plug in any numbers into it, just write it. So for the explicit, I'm going to use the 0 term, which for this one is negative 72, and use d, which is 14, to write it as negative 72 plus 14x. There you go. So plus d times x plus 14x. I'm going to flip that around. And then later in the video, I'm going to show you again how to use not just the 0 term in d, but the first term in d, the x minus 1. So make sure you pay attention to that when that's coming. So for this, my recursive is f of x minus 1 plus 14, and my explicit is 14x minus 72. Don't forget to write that f of x in there to make it complete. So f of x equals f of x minus 1 plus 4, and f of x equals 14x minus 72. For number 3, I'm going to do the same thing. I'm going to find, for this one, which will be geometric, what number I'm multiplying by. So if I take 260 and 130 and 65, I can see it's going down by a factor of 2 is dividing by 2. But remember, dividing by 2 is the same way as multiplying as a reciprocal of 2, which is 1/2. So dividing by 2 is the same as timesing by the reciprocal of 1/2. So my common ratio is 1/2, which means going to the left, I'm doing the opposite of timesing by 1/2. I'm multiplying by the reciprocal of 1/2, which is timesing by 2. So to find that 0 term for this, I'm going to take that 260 and multiply by 2, which gives me a big number. So you can see larger as I go to the left because I'm multiplying by 2, smaller as I go to the right because I'm timesing by 1/2, which is the same as dividing by 2. So timesing by 2, doubling to the left, having timesing by 1/2 going to the right. So if I take that 260 times 2, that will give me what that f of 0 term is, which is 520, I believe. So again, you can see that is the largest number in the sequence, and that makes sense. That is my 0 term. So to find my recursive function, I'm going to use both this time and then go back and show you the other one. So I'm going to use f of x equals f of x minus 1. That part's always the same. Again, saying to find any term, use the 1 before it, times the common ratio for this one, which is 1/2. So that is the recursive function that represents this sequence. Taking the 1 before it and timesing by 1/2 to get the next one. Explicit, I'm going to use both the 0 term. So start off with plugging in the 0 term, which is 520. I'm sorry. And I wrote 560. And let's just pretend that is 520. I'm not sure why I wrote 560 there. So again, my explicit is 520 times 1/2 to the x. Or I could use the first term times 1/2 to the x minus 1 power. So make sure you're okay with both. So again, make sure you know this should be 520 right here, because 260 times 2 is 520. I'm not sure how I wrote 560, but 520 times 1/2 to the x, or 260, the first term, times 1/2 x minus 1. Make sure you're okay with both. Recursive, always the same. So for the next part, I'm going to go back and show you that I want you to know how to do both the explicit for the zero term for arithmetics and D. So if we go back to number 2, I had you find the explicit function 14x minus 72 by using the zero term in D. And then for this one, I want you to also be able to find that using the first term times d to the x minus 1. So again, if I take the first term in the sequence, negative 58 plus d to the x minus 1, and I distribute that 14x and negative 14 and combine them, I will get the same answer. So make sure, again, you're okay with both. Finding this explicit using the zero term in d, or the first term in d to the x minus 1. Just like explicit, using the first term times d to the x, or the zero term times d to the x, or the first term times r to the x minus 1. Sorry about that again. So make sure when you're doing these, know how to do both with the first term and the zero term. All right, number 4, a little bit easier than it looks. I give you the first term is 5. I give you your multiplying times 3. I want you to find the next 4 terms. So if you take that 5 and multiply by 3, you'll get the next term. And then if you take that and times by 3, you'll get the next one. Notice it is the explicit. You're not having to plug in and do any of that function notation. You're just using the idea of the explicit function, using 5 and timesing by 3 to get that next number, and timesing by 3 to get that third number. So again, taking the first term 5, timesing it by 3 gives me the next term 15. Taking that 15 times 3 will give me the next term, which is 45. And then that goes right there next to the 15. And then when I take that 45 times 3, I'll get the fourth term in the sequence. So 45 times 3 gives me 135. And then to find that next term, I take 135 times 5, which gives me 675, which I'll change here. So again, those next 4 terms, starting with that 5 and timesing each one by 3, 5 times 3, 15, 15 times 3, 45, 45 times 3, 135, 135 times 3, 675, finding the terms using the recursive pattern. All right, next problem. Has you simplify to see which of these choices are the only one that gives you 4x plus 1. So I'm going to write each one out and show you which one of those 4 gives you 4x plus 1. So here we go. Choice A is 1 minus 4 times x minus 1. Remember, you distribute that negative 1 all the way through, and that gives you 1 minus 4x plus 4. And then right away, when I combine, I'll get negative 4x plus 3. As soon as I see that negative 4 in front of x, I know it's not matching that. That is the wrong choice. Choice B, again, 5 minus 4 times x minus 1. I'm going to distribute that negative 4, which gives me negative 4x plus 4. And then when I combine like terms, again, you can see the common difference is negative 4x. That is incorrect. That doesn't match 4x plus 1. So when I do choice C, I get 1 plus 4 to the x minus 1, distribute 4x minus 4. That gets close. I get 4x minus 3. I get the same common difference, but when I combine these like terms here, I get negative 3, and that's not correct. So that is incorrect. So my last choice is D. 5 plus 4 to the x minus 1 gives me 5 plus 4x minus 4. The 5 minus 4 combines to give me positive 1. That is the correct choice, 4x plus 1. So that one is D. Those are equivalent. All right, 6 has you label the graphs. So just remember, for 6, if the graph shoots up like that, it is exponential. That is a geometric graph. If it's a straight line that's linear, that's a arithmetic graph. Exponential represents geometric sequences. Linear graphs represent arithmetic sequences. Straight line, linear, arithmetic. Curved line, exponential, geometric. All right, 7. 7 has you use the explicit function for this geometric, and I can tell because it's times 2 to the x power. I'm going to plug in all 4 numbers. So using this function notation now, I go f of 0, that's the notation, equals 3 times 2 to the 0. Here's where I'm doing the actual math. Anything to the 0 power is 1. Don't mistake that for 0. So that 2 to the 0 power becomes a 1 right there. And then 3 times 1 just gives me 3. So f of 0 is 3. When I plug in 1 into that same function, plug in 1 where x used to be, I get f of 1 equals, and again this is the notation part, over here equals 3 to the 2 times x to the first power. Here's where I'm going to do the actual math. So again, don't times before you do the exponent. That gives me 3 times 2 to the first power, which is 3 times 2, which is 6. So the first f of 1 is 6. Alright, when I plug in 2, again, where that x used to be, I plug in 2, so I get 3 times 2 to the 2 power. Make sure, again, you do 2 to the second power first. Gives me 3 times 4. 2 times 2 is 4. And then f of 2 is 12. And then my last one, plug in 3. So I get f of 3 equals 3 times 2 to the third power. Remember, 2 to the third power is 2 times 2 times 2, which is 8. That gives me f of 3 equals 3 times 8, which is 24. So those 4 numbers, when I plug in 0, 1, 2, 3, give me f of 0 is 3, f of 1 is 6, f of 2 is 12, and f of 3 is 24 in that order. And you can see that is geometric timesing by 2, the common ratio each time. Alright, last one. Gives you some choices and says which one is the bad one. So the sequence here, 4, 7, 10, 13, you need to again find all the information. You need to take that sequence, 4, 7, 10, 13, find the common difference. You need to use the opposite operation to go back and find the 0 term. So if I'm adding by 3 going to the right, subtracting by 3 to the left, 4 minus 3 is 1. So again, with that combination, I could answer the wrong choice. So choice A is f of x equals f of x minus 1 plus 3. It has the recursive form with the correct common difference. That is correct. That represents that sequence. That is not what the question's asking for. It's saying which one does not. That one does, so that one's okay. Leave it alone. Next one. If I plug in the 0 term plus d times x, I get 1 plus 3x, which flipped around is 3x plus 1. That does also represents the sequence. So that answer, again, you want to leave it alone. That one is good. That represents the sequence. Choice C, when I plug in those, you will see that choice C of all of these has the different number in front of that x there, has a different number for the common difference. You know that one is not going to be correct. So let me show you. So for this one, I get 1 plus so choice C is 1 plus 4 times x minus 1. You can see right away does not have the first term. It does not have the common difference number. That is the bad choice. You want to circle that. You can tell again. Does not have the common difference number in the right place. It's not 4. It should be a 3 there. Choice D is okay because D has the first term plugged in there, f of 4, and then the right common difference number. Again, this will distribute 3x minus 3. And the 4 and the minus 3 will combine to give you that same 3x plus 1. Remember, these are all equivalent. They all represent the same sequence. Hopefully this video will help you. Good luck.